being an entrepreneur, you want to do things a little bit different.
Yeah.
Right. You want to do something maybe an old way, but also break into a new marketplace. And the way we did that is like, okay, well, what we want to do is additive manufacturing. And we wanted to do kind of quick turnaround. And we know that engineering time is a lot of your costs and a lot of your effort. And we want to be able to pump that stuff out. And it really just fed into rapid prototyping for startups. And everybody here in Grand Forks is like, hey, you got to talk to the drone industry.
Welcome to Hangar X Studios, where former fighter pilot and host John Ramstead takes us on a journey across aerospace as it enters an historic period of innovation and transformation. Our guests include aviation experts, pilots, financiers, military leaders, and innovators of all types. Buckle up for another episode of Hangar X.
Today's episode is brought to you by our platinum sponsor, XTI Aerospace. They are powering the vertical economy, building a long-range VTOL, and you can find more at xtiaerospace.com. Now, please remember to like, comment, and share on this channel, and enjoy today's podcast.
Welcome to Hangar X Studios, and we are live at the Hive in Grand Forks, North Dakota. And I'm excited today. We're going to be talking about manufacturing. You guys have heard about 3D printing, rapid prototyping, manufacturing, fixing parts, improving on processes. So we brought on today Aaron Hall. Aaron, first of all, welcome, and thanks for coming to the podcast.
Thanks. Appreciate being here.
And you got an incredible company, Bifrost Manufacturing. The website is killer. Plus, I'm Norwegian. Plus, I wanted to name my son Thor, but I got vetoed. He might appreciate that. I'm not sure, but I really want to talk about today what you do. So we're going to talk about what this crazy thing is, and what some of these parts and pieces that you've made. But before we do that, I'd love for you to talk about, hey, what you guys formed Bifrost back about 2 years ago, and it's taken off rapidly. There is a huge need for what you guys are doing. I know that. One of my clients is building some rapid prototyping of actually a flying version of their aircraft.
Yep.
But actually finding and creating the parts from the CAD/CAM system to actually test our theories.
Absolutely.
Right. In the past, this would have been years and millions of dollars, and things have changed. But tell us about how Bifrost came to be.
So when we started Bifrost, it was just out of need. I started another company. We do infrastructure for data centers and Bitcoin mining. And we were kind of running into this issue where we would have, we're in kind of this new grassroots industry, and we're setting these co-located data centers on the ground, essentially what they are. And they don't operate in, I would call, the world's harshest environment as designed. So we're cutting on them, and we need work done. And we're getting to a lot of these guys, and things you experience is millions of dollars to wait a year. And we need these fixes yesterday. It's a very high value, high dollar amount turnaround. Like, we can't wait.
Like, what kind of fix? What would be an example of something?
Hot aisle containment. So you take you got to make sure that your intake and your exhaust and your mining operation is separate and it's sealed. There's a pressure barrier there. So what we did is, and the more robust the pressure barrier, the more effective it is. So you can't just take, polycarbonate and cut, like a political sign and cut like a little hole in it.
Right.
So what we did is we did CNC cut steel, and we formed them to the back of our shelves, essentially. Okay. And so that was just one simple fix, right? And then there's all the fittings and all the whatever. And we go to these places, we say, hey, I need a $45,000 order in the next week. And they say, I don't remember where I put the file. And we're like, so we knew Killian, and we said, hey, Killian, what are you doing this weekend? And I don't know. We should come down to the shop. And it just, he's kind of moping around the shop doing work, and his phone's ringing all the time. Well, I don't do that anymore. We're like, well, who was that? Well, that was Cirrus.
You're thinking, maybe we should do that.
I was like, well, you gotta stop saying no. So then we kind of leapt into.
Oh, you said Cirrus called. So big companies are calling.
Absolutely.
Because they need pieces for their prototyping.
Well, a lot of it is tooling. So
okay.
The companies I'm allowed to talk about are like LM Glass Fiber, Cirrus Aircraft, and a lot of it is tooling and, just fixes. And being an entrepreneur, you want to do things a little bit different.
Yeah.
Right? You want to do something maybe an old way, but also break into a new marketplace. And the way we did that is like, okay, well, what we want to do is additive manufacturing. And we wanted to do kind of quick turnaround. And we know that engineering time is a lot of your costs and a lot of your effort. And we want to be able to pump that stuff out. And it really just fed into rapid prototyping for startups. And everybody here in Grand Forks is like, hey, you got to talk to the drone industry. you guys are set up to do drones. So that's what we started to do, is we started to go to, the UAS conferences. We went to,
Right.
we went to San Diego and kind of got the feedback on what the industry needs are.
And did the drone industry say, hey, we need this?
Absolutely.
Because you thought the classic car industry was going to be a home run.
Yeah.
And it was a bit of crickets, but
No, it wasn't even a bit of crickets. It was like total crickets. Like it was absolutely like dead silence. I was sure that like some guy would come in and be like, this ashtray is the only thing I can't get from my 1970 Dodge Charge, and I'll pay $4,000 for it. And it was just absolutely
no.
It was just like blank stares when you look at them. So I will admit, classic cars were not a thing, but we also thought ag, right? So like you take these parts and they're printed out of steel, and these are 3D printed and laser sintered, and they're actually, what they are is they're essentially a big weld. So they're stronger than cast steel. So what we thought we would have is agriculture as well.
So if I had a broken tractor and I needed a part that might take me 2 months to get,
Yep.
I can go to you guys, take the broken part, you scan it with this thing. We'll talk a little bit more about this. I can actually print it, and I can go get my tractor running in a day or two versus a couple months if it's done.
Correct.
Same thing with an entire gear for a engine assembly or my cooling system, whatever it happens to be.
Yeah, so this thing's a pretty good representation, so this is actually a part for an industrial snowblower.
Okay.
And we've now kind of tested this, and not just steel, but also the SAF, so the nylon printing. It's actually quite durable. But this gives you an idea, because if you see on the front or the back,
Yeah.
that's what it looks like when it's machined and finished. But this is what it looks like when it comes out of the. So it's a little bit rough. It's got a little bit of texture to it.
Yep.
But yeah, the solutions are kind of like based on the customer, right?
Yeah.
So we've got this marketing where we go, well, what do you want? And that's I think the struggle is the education. So it's important for us to come on podcasts and be like, well, what do you want us to make?
So, let's take educate us a little bit. So people that maybe aren't familiar with manufacturing or, fixing or prototyping, but what's the difference between injection molding? You mentioned the word SAF a couple times.
Yep.
I wasn't familiar with it. I've heard of 3D printing, but could you kind of educate us a little bit on the
Sure.
whole process and the differences?
Well, don't feel bad. I'm the business guy, and I heard of SAF like 2 months ago. It's actually it's brand new.
Okay.
So these parts are SAF printed. So I like this one because it's pretty cool. This is actually a speaker cover for a Rivian. So what SAF is it's a nylon 12, and it's a powder bed process. So what happens is it lays down a very thin layer of nylon 12, like less than a human hair, cures it, next layer, next layer, next layer, next layer. So what happens is we print.
So as it's curing it, it's making that?
Yep. And what
That's
comes
fascinating.
out? What comes out is, it's kind of crazy. Is that they call it a cake.
Yeah.
And so it's just a brick of nylon 12, and you like set it on the table, and you gotta it's like a little bit of a Jurassic Park archaeologist. You gotta brush them out of there. And
Oh yeah, like
what you do
the
is
stuff I used to buy my kids when I was, visit the museums.
100%.
Okay, cool.
It's exactly what it is, but way bigger, and it gets everywhere. Well, I suppose that stuff does too. But so why SAF is comparable to injection molding is more in the term of price. So the way SAF changes the game is it's all fast and cheap. Nylon 12 as a material is fairly, I would say, cost effective. And the boundaries you're running on is the whole cake itself. So if you only have to buy, a couple parts to fill the cake, your costs are low.
Well, you said, if this was a part that I needed, I wanted to prototype it, but to do it in this process, that I'd probably get 40 of these, even if I needed one.
Well,
But it's the
we
same
can give you
price.
one, but it's going to be the same price. Yes,
Because you got to do a whole cake. But it's only a few $100s.
That's correct.
And if I wanted to do injection mold something like this because I really needed it, what's the time and cost of something like that?
Oh, man, that's a hard one. So injection molding, you're probably going to go to South America or China. You're going to spend millions of dollars in tooling because they need to make.
Okay, so not even comparable.
Well, it is, because once you get to the end product, if you're doing 100,000 pieces, it's going to be cents. But if you're doing less than 100,000, you're going to want to do 3D printing.
Okay.
And so as a startup, I don't think any drone company is going to do 100,000 of any piece.
No.
And then the issue with injection molding is if you're any part of the prototyping process,
Yeah.
you can't change it, because then you have to change all the tooling.
Right.
This, we can change every print.
So show us some of the things that you printed, these other pieces, and tell us what this thing is, because it's pretty cool.
I'll start with this thing. So you roll in. This is a Creoform blue laser scanner. And what this does is it really just narrows down I'll hold her up here. it really narrows down our engineering time. So we can, for example, we had an old Marine colonel come in the other day, and he had it was like a 1930s antique pistol, and his leather maker was in Washington State, and he didn't want to ship the gun because it was special to him. And he's like, guys, can you help me here? We're like, yeah. We scanned it in a matter of 15 minutes and just printed out a replica for him to send. Now, in that case, it's just kind of a easy fix for an old Marine colonel, but for a startup who's rapidly prototyping their parts, they now have a huge, I would call it industry advantage, because everybody else is moving in chunks of 3 to 6 months.
Well, I can see this. Like, let's say I'm building something, and this is a gear that I had, and a tooth broke off, and I need to get this replaced, and
Absolutely.
It's going to be months. So you could scan this,
Yep.
fill that in the CAD system, go print it, and now I'm back prototyping.
Correct.
I mean, so it's
Or you're this is a little intake housing.
that's heavy.
It's tool steel.
Yeah.
But so your intake changes, right? Just the dimensions of this.
Yeah.
You'd have to change all your tooling, or we can just go in the CAD and stretch it out a little bit and reprint.
Reprint it and try it. Try the new one. Try the new one. Try the new one.
And the other thing about SAF is it includes resin in the process. So I think it's this part here is just SLS. So this is
What's SLS?
this would be sintered nylon. Without the resin. SAF is a little bit different. It's more durable. So then you could, if you feel, I don't know if this really translates well, but if you look in here, you can feel the walls of this are very thin.
Yeah, very thin, but they're also very feels very
Right.
like there's strength to it.
Yes. So
Tensile strength.
yes. So in the drone industry now, you can reduce your weight significantly and still keep a lot of your strength, which means more payload, more flight time.
Yeah.
So I think this is going to be quite the game changer. And I brought when we go to, I don't know, we do sometimes throw robotics competitions and whatnot. And, we go to just conferences. We like to hand out stuff for the kids. And so this chassis is 3D printed, and this is a micro racing drone.
It has your Bifrost logo on there.
Well, yeah, of
So,
course.
so you got a micro racing drone that you basically 3D printed.
That's right. Just the whole chassis. You can feel it's pretty light.
Oh, it's very light.
The interns
A
like
few
to-
ounces.
They're big fans of flying them around and crashing them into people's offices and stuff. So we always have quite a few of those around. Yeah.
That's awesome. So what does the next year look like for you? I know there's some things you're under NDA. You're working on some really interesting projects that could really kind of blow up in a good way, some things you're doing.
Absolutely.
What does the next year look like for you guys?
I think the big one is, we have the things we're working on now, which are more, I think, defense related. So flyaway parts is we're in a couple processes where our machine specifically will go through characterization studies with, bigs that will then certify them to, the FAA says, hey, yeah, this process, okay. Now that is on the horizon.
If I understood you right, you're basically saying there might be a path to actually use the work you're doing
Correct.
to put replacement parts on certified aircraft
That's correct.
as part of a signed off for A&P repair process.
Yeah. So the whole,
Which could cut down costs and
Yes.
and increase availability.
yeah, this whole industry, as you probably know, evolves very rapidly.
Yeah.
And then, the FAA is what they're trying to do is they're trying to say, hey, we want to not just certify like this part, because what if they have to change it? And they're looking now more at processes,
Oh, let's certify a process.
which is, it's smart, especially when you come to the 3D printers. I told you when I came here is like, everybody wants to know what's your widget. And it's like, well, if it fits on a build plate. So now the FAA has to think differently and be like, well, if it's made on that build plate, then it should be certified kind of deal. That's one of the things we hired. His name's Will Swearson. Mm-hmm. Will comes to us from Northrop Grumman as one of their senior engineers. And Will is, he wants to target DARPA.
Yeah.
For, right now he's working on hypersonics is one of them, high hypersonic interception. And then there's a couple other things. But I think research and development would be another stage that we really want to focus on.
That's pretty cool. And you're up here in Grand Forks, and
Absolutely.
there's quite an ecosystem of drones and UAS, and there's probably a lot of customers up here and growing.
Absolutely. Oh, yeah. You see that a lot. It becomes more sophisticated as time goes on with the money that's involved.
Yeah.
You're seeing less and less just, I would say, pie in the sky. I have an idea, but actual, pre-seed or Series A or companies that are funded and motivated to, make a product.
Yeah.
So I think it's definitely evolving as time goes on.
Yeah. Well, that's awesome, man. Well, keep up the good work. I look forward
man.
to
Thanks.
catching up with you as we're up here,
Sure, for sure.
and just hearing about some of these big projects. As you can talk about them, we'll have to have you back on.
Oh, for sure.
And some of them I have some big implications.
Okay. Yeah. Hopefully.
yeah.
What, man? Hopefully.
All right.
Thanks.
All right. Thanks for everybody for listening, and we'll talk to you soon.